Hello everyone, welcome back to my channel, Ma'am Balot's Math Tutorial. This time we will be discussing more problems on arithmetic sequence. Example number 1. If a sub 4 is equal to 17 and a sub 9 is equal to 62, find all the missing terms between them. Of course, we are assuming that these terms are on an arithmetic sequence. So from this, we have to insert 4 terms between 17 and 62 since 17 is the 4th term and 62 is the 9th term. And we will be using the formula of the common difference, which is D is equal to A sub n minus A sub 1 over n minus 1. But instead of using A sub 1, we will use A sub 4 since A sub 4 is the given term of this example. So the formula now becomes D is equal to A sub 9 minus A sub 4 over 9 minus 4. And if we substitute now the 4th and the 9th term, that becomes 62 minus 17 over 5. And if we subtract 62 and 17, that is now equal to 45. So 45 divided by 5 is equal to 9. So 9 is the common difference of this arithmetic sequence. So we have now 17 plus 9 is equal to 26. Add another 9, we have 35. Plus 9, we have 44. And add another 9, we have 53. So the missing terms between 17 and 62 are 26, 35, 44, and 53. Example number 2. Find the sum of all multiples of 6 between 4 and 68. Since we are only adding the multiples of 6, so our first term cannot be 4, but it would be 6. And our last term is not 68 because 68 is not a multiple of 6. So our A sub n would be equal to 66. Since 66 is the biggest number below 68, that is a multiple of 6. But before getting the sum, we need to know how many terms we have to add. We had to find n. And from the formula of the nth term of the arithmetic sequence, we can derive the formula of n as n is equal to A sub n minus A sub 1 over D plus 1. And we know that D is equal to 6 since the terms are multiples of 6. So we substitute now the different values to our formula. We have now 66 minus 6 divided by 6 plus 1. So subtracting 66 minus 6, we have 60. So 60 divided by 6, we have now 10. And then 10 plus 1 is equal to 11. So therefore, n is equal to 11. So from this, we can now solve the sum of the multiples of 6 between 4 and 68 by using the formula of the sum of the arithmetic sequence, which is S sub n is equal to n over 2 times A sub 1 plus A sub n. So substituting all the variables, we have now S sub 11 is equal to 11 divided by 2, since our n is 11, times the first term, which is 6, plus the last term, which is 66. So adding 6 plus 66, we have 10. And then we divide first 72 divided by 2, that is now equal to 53. So the missing terms between 17 and 62 are 26, 396. So 396 is the sum of all the multiples of 6 between 4 and 68. Example number 3. Find the sum of the first 15 terms of the arithmetic series whose general term is A sub n is equal to 3 minus 8n. In this example, we need to find first the first term and the last term. But we know already that our n is equal to 15. So in finding the first and the last term, we have to use the formula of its general term, which is a sub n is equal to 3 minus 8n. So we just substitute n to our formula. So finding the first term, we have now a sub 1 is equal to 3 minus 8 times 1. So 8 times 1 is equal to 8. And then 3 minus 8 is equal to negative 5. So our first term is negative 5. Finding now the 15th term, so we have a sub 15 is equal to 3 minus 8 times 15. So 8 times 15 is equal to 120. And 3 minus 120 is equal to negative 117. So our 15th term is negative 117. So we are now ready to find the sum of those 15 terms by using the formula of the sum of the arithmetic series. So we have S sub n is equal to n over 2 times a sub 1 plus a sub n. So substituting to the variables, we have now S sub 15 is equal to 15 over 2 times negative 5 minus 117. So adding up negative 5 and negative 117, we have 120. And 3 minus 120 is equal to negative 117. So our 15th term is negative 61. Then multiply by 15, we have now negative 915. So the sum of the 15 terms of that arithmetic series is negative 950. Example number 4. Which term is 52 in the sequence negative 18, negative 11, negative 4, 3, and so on? In this sequence, we know that first term is negative 18, the nth term is 52, but we don't know what is n. So, we will now use the formula of n that we had derived before, which is n is equal to a sub n minus a sub 1 over d plus 1. So, we know here that our d is 7. Since adding 7 to the terms given will give us the next term. So, substituting now to the variables, we have S sub n is equal to n over 2 times a sub 1 plus a sub n. So, substituting all the variables, we have now 120. And 3 minus 120 is equal to S sub 15 is equal to 15 over 2 times negative 5 minus 110. And then 10 plus 1, so we have now 11. So, n is equal to 11, which means that 52 is the 11th term of that sequence. Example number 5. How many consecutive positive even integers must be added to obtain a sum of 1980? So from here, we know that a sub 1 is equal to 2 since we are concentrating on even integers. The common difference is 2. We don't know what is n, but we know that the sum is 1980. So using the formula of the sum of the arithmetic sequence, which is S sub n is equal to n over 2 times 2a sub 1 plus n minus 1 times d. So we substitute here the different given. So we have S sub n is 1980 is equal to n over 2 times 2 times 2 plus n minus 1 times 2. So, from this equation, we need to find the value of n. So, we have to multiply first 2 times 2, that is now equal to 52 is the 11. We distribute 2 to n minus 1, that becomes now 2n minus 2. S sub 11 is equal to 11 divided by 2, since our n is 11, times 2. And then, we cross multiply 1980 to 2. So you have now, we distribute 2 to n minus 1. That becomes now so from this, we can now solve the sum of the 53. So the missing terms between 17 and 62 are 26, 35, 44, and 53. 2n squared plus 2n minus 3,960 equals 0. So from this, we will divide the whole equation by 2. So that becomes now n squared plus n minus 1,980 equals 0. In solving for n, we need to factor out this quadratic equation. And the factors now are n minus 44 and n plus 45. After that, we equate both factors to 0. So that is now n minus 44 is equal to 0 and n plus 45 is equal to 0. Solving for n, we have now a sub 1 is equal to 3 minus n is equal to negative 45. But since we are looking for the number of terms, so n cannot be a negative number. Therefore, negative 45 is an invalid result. So we go for n is equal to 44. So therefore, there are 44 consecutive even positive integers that sum up to 1,980. Now it's your turn to answer the module. Don't forget to like and subscribe, and please hit the bell so that you can be notified for more videos. Thank you so much. At your service, Ma'am Balot. Momo.